Protons can be accelerated to speeds near that of light in particle accelerators. Let's estimate the de Broglie wavelength in nanometers of such a proton moving at 2.90 times 10 to the 8th meters per second. Given that the mass of the proton is 1.673 times 10 to the negative 27 kilograms. So what equation are we going to use? Well, the de Broglie equation says that the wavelength is equal to Planck's constant divided by the mass times the velocity. Planck's constant is something you should know. It is 6.626 times 10 to the negative 34 joule seconds. The mass is given to us. The mass is 1.673 times 10 to the negative 27 kilograms. And the velocity is given to us. The velocity is 2.90 times 10 to the 8th meters per second. Speed of light is 3.00 times 10 to the 8th meters per second. So you can see that we are very close to the speed of light here. So this looks like a fairly simple problem. Let's start plugging numbers in here. The wavelength is equal to 6.626 times 10 to the negative 34 joule seconds divided by the mass, which is 1.673 times 10 to the negative 27 kilograms. And the velocity was 2.90 times 10 to the 8th meters per second. So let's go ahead and plug this into our calculator. 6.626 times 10 to the negative 34 divided by 1.673 times 10 to the negative 27 times 2.90 times 2.90 times 10 to the 8th. Okay. And so I get an answer of 1.37 times 10 to the negative 15. But what units is this in? So we want our answer in nanometers. Right, we asked for the question, asked for an answer in nanometers. What sort of units do we have here? Well, it looks like we have joule seconds, we have kilograms, and we have meters per second. At the moment, the only thing canceling out here are our seconds. This leaves us with joules divided by kilograms meters. Huh? How in the world are we going to get an answer in some sort of length measurement? Well, the thing that's important to remember is what a joule is. A joule, 1 joule, is equal to 1 kilogram meter squared per second squared. Okay, a kilogram meter squared per second squared. So if we were to break these units out, we would have kilogram meter squared per second squared times seconds, right? That's this piece here, divided by kilograms times meters per second. So the kilograms, let's change colors here so we can see what's going on. The kilograms are going to cancel. Kilograms cancel. One of the 2 seconds are going to cancel here, right? This one and one of those. We have one more down here, so that is the second set of seconds. And one of the meters is going to cancel. So you had meters squared. Let's cancel one of them, leaving just plain old meters. So this gives us an answer in meters, 1.37 times 10 to the negative 15 meters. We wanted our answer in nanometers. So a simple conversion here, I meant to turn that to black, but that's fine. 1.37 times 10 to the negative 15 meters. Anybody remember the meter to nanometer conversion? Okay. 1 nanometer is 1 times 10 to the negative 9 meters. So our meters will cancel, and this will leave us with nanometers. Now, you don't actually have to put this in your calculator if you're comfortable using exponents. If not, go ahead and put it in. But this should give you an answer of 1.37 times 10 to the negative 6. Oops. nanometers. 1.37 times 10 to the negative 6 nanometers. Thank you for listening.